So we are going to start the lecture number 3, economic equivalence. This is quite simple. Not simple, but I mean, it's important, but we will understand quite quickly. So what we know is that using the future value formula, we are able to find the future value of any investment today, or even we have learned of any investment or any withdrawal over any time of period. So we are able to calculate that. What are going to think about now is if I have different investment proposals at different times and with different cash flows, how I decide what is the best investment for me. So this is a common problem for engineering economics, to have 3 different projects, 3 different engineering projects to invest. I have facility 1 project, facility 2 project, and facility 3 project. Each one was with its own economics, cash flows, investment, expenses, revenues, and so on. So how do I decide what of the 3 projects is better? So that's the sense. It makes sense to have a methodology to decide between different cash flows patterns. So that's the target of lecture number 3, economic equivalence of different cash flows. So we are putting the stress of our knowledge now in comparing different cash flows and having a common rule, economic rule, to compare cash flows and to decide which one is better for us. Of course, better for us will be the higher present value. So do you remember the Lisa's lottery case? He won a lottery, and she was offered to receive one lump sum today. Lump sum is just one single amount today, big amount today, or receiving during 26 years small payments every year. So what will be the economic decision of Lisa? She doesn't know how to decide. So what Lisa needs is economic equivalence formula to compare. So that's we are going to understand. Challenging issue: how do you compare 2 different money transactions? In general, for example, will you choose an option 1, which is not having money today and into money today, but receiving 1,000 euros in 1 year from now? Or do you prefer the option 2, which is not receiving any money for the next 3 years, and at the end of third year, receiving 1,200 euros? What do you prefer? Have you got any rule to decide about that? So another option could be, or whether we prefer to have 20,000 euros today, or 50,000 euros in 10 years from now, or alternatively, do you prefer to have 8,000 euros each year for the next 10 years? Every year, it's 8,000. So we need a rule. So the economic equivalence problems can be summarized with these 3 questions. What do we mean by economic equivalence? Why do we need to establish an economic equivalence? How do we establish an economic equivalence? So why do we need? Why do we mean? Why do we need? How do we do? Economic equivalence is a financial calculation, as I have explained, for determining the economic effects of one or more cash flows. So it's a financial calculation. It is the main idea, to determine the economic effects. So we are going to see the economic implication of every cash flow alternative. When we say that economic equivalence exists between cash flows that have been that have the same economic effect. So we are presented two different cash flows. We have to decide which one is better for us. We will decide when they have the same economic effect. Or if one has a different or better economic effect, we will trade with that financial asset, with that cash flow, instead of the other. So when we say that economic equivalence refers to the fact that any cash flow can be converted to an equivalent cash flow at any point of time, mainly to today. The main used point of time is today. So any cash flow, as we have seen, can be converted to an equivalent amount of money of today, money. So the present value of a sum of future cash flow is equivalent in terms of value for different future cash flows, because, and this is the most important thing, that what is the discount rate, what is the interest rate that makes two different cash flows equal in the present time, in the current time. So that's the main target of our problem, is to know the discount rate, the interest rate that makes two different cash flows equal. So this is the definition. Economic equivalence exists between cash flows that have the same economic effect. The same economic effect is the cash flow, the present value of the cash flows, and could be therefore be traded for one to another. So if they have the same economic effect, they have the same economic value, so I can choose either one. Even though that the amounts of timing of the cash flows may differ, an appropriate interest rate, the discount rate, makes them equal. So that's the key, that what is the interest rate that makes any cash flow, or both cash flows, or two or three cash flows we are trying to know, that makes them equal. So for example, we have two different options, two different investments. One is having today 20,000 euros, and in 10 years receiving another 50,000 euros. And the other option is having every year, 10 years from now, every year receiving an amount of 8,000. So you have here from n equals to 1 to n equals to 2 to 10, you have 10 equals payment of 80,000. 8,000. Have you got any rule to decide if you prefer option 1 or option 2? So the rule is that if both financial proposal, option 1 and option 2, have the same monetary value today, then this is economically indifferent choosing between them. So if they have the same value today, this investment and this other investment, they have the same economic value today, you don't have any, you are indifferent about them. So you can invest either, but depends on the interest rate. So this is the other basic formula of engineering economics. We know this one, which is the future value of any investment today. We deposit an amount, a principal amount today, and in n years or n time later, we will have a future value of this present investment. The future value, we know the general compounded interest, the principal amount times bracket 1 plus a to the nth power. What we call this process in terms of moving the money from today to the future, we know we use the term to capitalize, to project, or to compound. We know the word compound. Another synonyms are to project the present value, to project to the future value, or to capitalize a present value to a future value, are the same word, the same concepts. How do we calculate the inverse? The inverse process is, if I have a future amount of money, I'm offered a future amount of money, how much is worth this future amount of money how much is it worth today? So this is the inverse process. We call this to discount the future value to discount to the present value. And this formula is the inverted formula of the compounded. So as you see here, the compounded value for future is principal amount times. What is the inverted formula? The present value of any future value. The present value is the future value times bracket 1 plus a to the minus nth power, which means it's the same that f, the future value, divided by 1 plus a to the n power. So that is the basic of engineering economics, both formula. The future value of a present amount and the present amount of a future, the present value of a future amount. So we know how to, we are going to learn how to apply and how to establish an economic equivalence. So we are offered two different investments, investment 1 and investment 2. Investment 1 is that you are offered to receive 207 euros, 2007 euros 5 years from now. Or the investment 2 is, okay, I give you today 1,500 euros and no more money. So what will you prefer, investment 1 or investment 2? Investment 1 is to receive 5 years from now 2,007 euros. And the other investment is receiving today 1,500. So what we do, the first thing is to establish an economic equivalence, is to know the present value of the future amounts, usually at the moment today, at the time n equals to 0. So as we have the investment 2 is based on n equals to 0, we don't have to do nothing with investment 2 because it is based on n equals to 0. So what we have to do is to find the other investments or the other cash flows which are based on different instant of time, different times, like investment 1, which is based on n equals to 5. So we are going to move a future value to a present value, to a n equal to 0. How? Which formula are we going to use? We are going to use the formula of moving from future to the present. So that formula moving from the future to the present is the inverted formula of compounded. So it's not the direct compounded, it's the inverted compounded, which is the present value of future value is equal to the future value plus 1 plus a, bracket, times bracket 1 plus a to the minus nth power. So this is the general formula we are going to use. And then the second step is, as we have said, investment 1 and investment 2 are economically equivalent when we find a certain interest rate that makes both investment equivalent today. So we are going to find the interest rate that makes a future value of 2,007 euros to find the interest rate that makes that equal to a present value of 1,500. So this is the step 2. Identify the interest rate to use. And then calculate the third step and the last, calculate the equivalent value at the base period n. So the general formula is the present value equals to the future value times bracket 1 plus the interest rate we are testing, close bracket to the minus nth power. So this is a proof and failure methodology, and we can start with an interest rate of 3%. What does it mean? The exercise I'm going to do is, if I have today 1,000, if 5 years from now I have 2,007 euros, if I discount 2,007 euros to the interest rate of 3, how much is worth today? Inversely, you can say, what is the present value of what is the present value that at a 3% of interest rate makes the worth in the future equals to 2007 euros. So what is the present value? We can calculate 2007 times bracket 1 plus the interest rate we are testing, which is 3 in this case, minus bracket, close bracket, to the minus 5th power. It gives the result is 1,731 euros. So we try, and with 6% of interest rate, we calculate the present value. Instead of using 3% here, we use 6. And then the result is 1,500 euros. So, as we see, future value of 2007 in 5 years is equal to a present value of 1,500. In the case, the interest rate is 6%. What happened is the present value 100 of the investment 1 at a 6% is 1,500 is the same value of the investment 2. We have to decide if the investment 1 and investment 2 are economically equivalent. So as we see, the investment 1 is equivalent to investment 2 at an interest rate of 6% because the present value of the investment 1 at the 6% rate, the present value is the same as investment 2, which is 1,500 euros. So we can test for a 9%, the present value of the future value of 2007 is 1,304 euros. So that's make us the question and solve our question that investment 1 and investment 2 are equivalent in the case of we have offered an investment at 6% interest rate annually. So as we can solve another problem is that this one, economic equivalence, a simple example, determine the interest rate that makes you indifferent to receive today 1,000 euros or receive in 5 years 1,762 and 62 euros, 0.334 euros. So are they equivalent? What are going to use is to use the formula. We have used it here, proof and failure procedure. What are going to use in this to solve this problem is to use the general formula. The future value of present value 1,000. The future value is 1,762, and we are going to see to find the I rate that makes both values equal, economically equals. So we clear I from this formula, and I is equal to 12. So at an interest rate of 12, the investment of investment 1, which is this one, is equal to the investment in moment 0, in time 0, which is this one, if we have an option of investing at 12%. So if we are offered today at rate of an interest rate of 12% for our 1,000 euros, you could accept for the promise of receiving 1,762 euros in 5 years. So both cash flows, this one and this other, are economically equivalent. So that's summarize the economic equivalence problem. So have you got any question? Let's see the chat. Okay. Someone has gone, ran out of battery. No, thanks. Okay, Maria. Then, okay, let's continue. Okay. So we have seen here a simple example. We have, as we are going to test the same example we have done before, we are going to find different options. Always the economic equivalence it is for the value of 12, but we can see what happened with the present value if the interest rate is 10%. So if we are offered a 10% investment for what is the present value, the amount I have to put in my account, to deposit in my account, for having in the next 5 years at the end 1,762 euros, at 10%, how much money I have to put in the bank today at that 10%. This is the present value. You have to put 1,094 euros. So why to choose this option, this investment at 10%, that you need to put more money than the previous one? We have to put with at 12%. If you want to get at the end of 5 years 1,700 euros, at a 12% you put today 1,000 euros. So why choose the interest rate, the alternative or the investment alternative at 10%, if the second investment at 12%, just put in 1,000 euros, you get the same amount in 5 years than put in today a higher amount, which is 1,049 euros. So the most logical thing is to put the less money today. But if you are offered not only a 12% investment, but a 14% investment, how much money you are going to put today, to deposit today? Less money than 1,000, you will be putting 915 euros. So which investment will you choose? I would like to ask you. If you are offered these different alternatives of putting your money today for having in the next 5 years 1,762 euros, what of the investment will you choose? Obviously, you will choose the highest, with the highest interest rate, because you are paid for your savings account. But what does it mean? That if you want to compare the result of having at the end of 5 years the same amount of the 3 different options, the way you choose the interest rate for the investment is because you need to put less money for having at the future, 5 years from now, the same amount. You will put today not 1,000 euros, you put less money, and you will save about 85 euros for using for another use. So which investment will you choose? The one with the lower present value, because you will disburse today less money for getting the same amount in the future. So put today 915 euros, today at an interest rate of 14 to get in the future 1,762 euros in 5 years. So I think this is clear. For example, you have to negotiate a loan with the bank. This is a common situation. We know there are some people who is not able to pay their loans, their mortgage, and they live in a house and they are an employee and they have a commitment with their bank. For example, they have a loan of in 5 years, they have a loan of 30,000 euros at 9%, and they have the obligation with their bank to pay every year 7,713 euros. So if you fail to pay today, you will have a problem with your bank, because your bank will want to execute the guarantee of the bank of the loan, which usually is the same as the house. So you will lose your house, and you can arrange a trade with your bank. So please, I am an employee today. I cannot afford every year to pay now, because I'm an employee 7,713 euros. Please, can we renegotiate the loan and expecting 4 years from now, 5 years from now, please bank, tell me the amount I will pay in 5 years. I will pay in just one payment in the future. I hope to have money in that future year, and I want to defer to not pay the next 4 years payment, and to defer at the end of the loan and to pay all the amount in the future. I hope my economic situation will improve. So how much money will our bank ask? They will ask 46,159 euros. So how does the bank calculate this amount? They use the same calculation, because they say, okay, you can do with your Excel, what is the present value of annually payments from year 1 to year 5 of 7,713 euros. What are the present value of each one of these cash flows? So if you apply the formula, the present value from 1 year from now, the present value to today of the payment of year 1, 7,713. So you calculate divided by 1 plus the interest rate, which is 9, to the 1 power. The present value of the second payment is 7,700 divided by 1 plus the interest rate, 9, to the second power. And then you sum all. If you use that formula, you will discover that the present value of those cash flows is 30,000 euros, which is the amount your bank is lending you the money. So we will see how this amount of 7,713 euros is calculated. That's just to know that the present value of these future cash flow streams are 30,000 euros, the same amount you have borrowed from the bank. Alternatively, you have arranged a different rate with your bank, a rate that you defer the annual payment, and you say, okay, I will pay you 5 years from now 40. The bank has said to you 46 and 159 euros. So if you calculate the present value at 9% in 5 years from now, and you calculate for today the value of 46,000 euros, the same future value is the same, is the present value, which is 30,000. So those cash flows, the Law 1 scheme and the Law 2 scheme, are economically equivalent. For the bank, they will get the same amount you borrowed from them, 30,000 euros. So you can make the study yourself. You see here. Okay, so at the end, the formula I am using is actual value. So you see here the minus convention we used before, and we are using a new formula which is the present value. We have seen the future value, and we are now seeing the present value, in Spanish VA. We see here in the formula the present value of these future cash flows of Law 1 payments is the sum of several payments. So what I'm seeing is a term for the cash flow in year 1 plus one term of present value for the second year payment, for the third year payment, plus the 4th year payment, and and for the 5th year payment. So each one of these terms, you see, for example, here for the present value of the first payment is C9, which is the interest rate, 9%. The second is the number of period. I have here an index here in the column A. I have an index from 0, 1, 2, 3, 3. Okay, so the number of period, the period of time, this is 1. For the second investment will be A4, which is 2. Okay, so this is the period of time you are discounting from. The second is the payment, which is the third is 0. The fourth parameter is the future value. In that case, is the same amount, the payment, the 7,700, and C1, which is the type. So if you calculate that, you will see that the present value of all those payments is 30,000. And you see here that for the 5 years from now payment of only single payment, lump sum payment of 46,000 euros, you see here that the value, actual value, the current value, excuse me, the present value is again the rate, 9%. Number of period is the number of periods you are discounting, which is in this case is the payment of the n equal to 5. 0 for payments, and then the future value is the amount, 46,000 euros, and then 1. So as you see, the present value of both investment at 9% are the same. So it means that the bank, in any case, in any loan payment scheme you can negotiate with them, they will calculate this value, the different cash flows, they will calculate for present value, and they will always get their loan, which is 30,000 euros. So I think this thing must be clear for you in order to your future lives. Okay, so the general rule is that equivalent calculation requires a common time phrases for comparison. So always we have to use the same time period for reference. So what we are going to see in this example is that if we want to know the future value or the amount of value of those payments, cash flows from from year 0, year 1, year 2, year 3, year 4, year 5, you can move all the cash flows to this period, and we want to know how much worth are those cash flows for the year 3. So what I'm going to use is to move all the payments, all the cash flows to the year base. We are using the base period year 3. So what I'm going to use is for cash flows that exits before year 3. What I'm going to use is to move for future is what we are going to use is the direct compound formula. So we have the present value and we are going to use the future value. How we calculate the future value, for example, of the first payment of year 0, 100 deposit. So is in year 3, the 100 euro of year 1 of year 0 is 100. This is the present value. We are using because we see here the positive sign in the power. We are seeing the positive and not the negative. So what are using is we are moving for future. So this is the direct compounded formula. The future value is the present value times bracket 1 plus the interest rate. We are using 10%. To the third power. Why to the third power? Because we are using to this period, which is, so the number of time periods are 3, which is the base period, less the period we are considering, so it's 0. What is the future value of cash flow 80 in year 1? Is 80 times the present value times 1 bracket 1 plus interest rate to the second power. Second, because this is the base period 3 minus 1, which is equal, no? You are having 80 euros deposited for 1 period and 1 period, 2 periods. and then and so on. What do with the third payment? If we are calculating the present value of in GR3 of an amount of GR3, the present value is the same. We don't have to move that amount, neither to the past, neither to the future. So if you see here in the formula for the base period 3, calculating the effect of cash flow 150 euros, we see here, which is 150 euros times 1 plus the interest rate to the 0 power. What is 0 not power? Because it's 3 minus 3. So this factor is 1, so we don't move forward or backward the cash flow of the base period. What is the result of moving future cash flows to present value in past? So, for example, the cash flow in year 5, 100 euros, we are going to discount. We are calculate, this is the future value, and we are going to use the present value. The present value is 100 euros times 1 plus the interest rate. And this is important because we are discounting, we are moving backward to the history to the minus 2 power. So I hope you understand this example because it's quite important for cash flow treatment. So have you got any question? I'm going to see. Could you show it with more? Okay. So this one, perhaps you meant another slide, no? Perhaps this one. Or okay, so please. Yes, Maria del Carmen, please. Which slide do you want with more zoom, please? Number 11. Okay. Oh, yes. When I open, no, you mean? No? I think it's quite big. Perhaps this formula, no? You mean? I don't know how really in my computer this doesn't happen. Oh, I see here, yes. I've moved this window. So you see all the formula. Okay. So is that okay? Okay. Is that okay? Okay, so let's continue it. Go ahead and so we are able at the end to find the future value. And then the question we have to review is for Lisa. Do you remember Lisa was offered to have today lump sum? This is the investment 2. She won a lottery and she was offered to receive $167 million today, or she received another option is to receive annual installment. Installment is like receiving periodic payments from year 0, from moment 0 to year 25. So this is mean 26 payments of every year of $10.57 million. So what do you prefer? Are they economically equivalent? That's the question we have to answer. So we know how to solve. How will you solve this one? This is an economic equivalent problem because we have two different investment opportunities with different cash flows, and they ask, what will you choose in what case? So this is the classical economic equivalence. So what we have to know to compare both is to find the interest rate that makes both investment equal in present time. So we are going to move all the cash flows in any of the investment to move to a present value, and then comparing or knowing which interest rate makes them equal. So as the second alternative, the lump sum, we know the present value because it's today. We are going is to concentrate in estimating, in knowing, in calculating the present value of this future stream of cash flows. So the problem is finding the interest rate that makes equally worth to invest now this amount at that rate instead of investing annually 10.57 million euros. So what the logical thing to think about is that if I have today a lump sum of $167 million, I will go to a bank to create a saving account and put in that money to work. So what interest rate? We are going to find the interest rate that makes that it is the same to receive the annual installment and the lump sum because the lump sum you deposit that amount in a bank account, so you will be receiving also periodic payments. So what the interest rate that makes them equal, no? So you have here the Excel balance. So you have here in column 1 is the alternative, the investment 1 is to receive every year, even also today, 10.57 million euros from today to year 25. So you will receive 26 installments of 10.57 million euros. At the end, you will receive an accumulated amount of 274.82 millions. So the other alternative is to compare with the receipts you will receive in option 2, which is 167. So if you compare the sum, you will say, okay, it seems that the sum of the option 1 is higher, 274, than the receipt of the option 2. But this is this methodology right, correct or not? I think it's not correct because we have to take into account the time value of money. So depends on what do you do with your 176.67 million euros, depends on what you do, depends on what interest rate you can get from your bank to create a saving account, that amount, if compounded along over 25 years, perhaps this amount today, the lump sum, will be higher than the future amount. So what's the important thing is not to think in terms of absolute numbers, but we have to think about the time value of absolute numbers. So we are going to calculate now is the present value of all these cash flows, every year cash flows. We are going to know the present value of today. So for example, what is the present value today of the 25th payment, which will be $10 million euros? The present value of this amount is 5 euros, less than 50%. So that's the effect of investment. So we are using several interest rates because we are going to find the correct or the interest rate that makes all the payments equal. So if we use the 3%, we see here that the accumulated present value of, this is present worth, all the payments at 3% is 194. So would you prefer the investment 2 or the investment 1 if the saving accounts you are offered is at 3%? So I think it's easier to decide. So if I give you today 167 euros at 3%, what you are going to receive is a lower amount that if you receive 10%, 10 million euros every year, because the present value, the present worth of 10 millions every year today is 194. So you will prefer that amount because it's higher, the investment 1, than the investment 2. What happens is the bank offers you a higher interest rate, for example, a 44.5%. We estimate, we calculate again the present worth of all the option 1 payments, and you will see that the present worth is the same than the lump sum, 167 million euros. So at a rate of 4.5, both cash flows are economically equivalent. So you will not have any rule in terms of economical rule to decide. You can choose either. What happens if the bank offers you a 6%? So 167 million euros deposited a compounded interest rate of 6% will produce a big amount. So the present worth of the option 1 is 145 million euros, which is less than the other option we have. So what will you choose from the point of view is you will choose, in that case, at an interest rate of 6%, which option will you choose? The option with the higher interest rate, which is the option 2. Excuse me, the option with the highest present value. So in that case, with an interest rate of 6, you will choose 106, the option 2. And if you are paid just at 3%, you will choose the option 1. If you are offered a 4.5, you can choose either, because the present worth of both investments are the same. So that's the original. And then if you write here the several options you can have, we are writing here in the x-axis, we are writing the interest rate, and here the present worth of the several alternatives. So in blue one you see the lump sum option, which always is the same present worth, 167. But the present worth of the installment option is different depending on the interest rate. So as you see here, the present worth in the case of interest rate is equal to 2, for example, you will choose the option of annual installment, because the present worth is higher than the lump sum. And in the case of the second option, the interest rate is 7, the same option is the inverse option. So you will prefer the highest present worth, which is having the lump sum today, because at 7% you will get more money in the future than at 10 million euros per year. So that is the end of the lecture number 3, the economic equivalence of different cash flows. So my intention for today was to start the lecture number 4, but I think it's time to finish the class. So have you got any question? So you don't have to look always to the interest. Beatriz is asking the following question. Reading in real time. Thank you, Beatriz, for your question. So you don't have to look always to the interest rate, because this time with a higher interest and a lower present value, you get less money. Is that right? Okay, I'm trying to understand. Because this time with a higher interest and a lower interest present value, you get less money. Okay, let me explain the foundation, the logical foundation of this one. Okay, so think in your pockets. First thing, I'm offering you to receive today 167 millions. You go to the bank and they offer a 3%, a 4.5%, or a 6%. Which one will you choose? Of course, you will choose the highest interest rate. In that case, you will choose the 6.0% interest rate. Why? Because if you put your money to work today, 167 million euros to work today at 6%, you will get, if you multiply, this is an easy amount I'm going to do with my calculator, for the next year, 167 million euros with a compounded interest of 6%, I multiply that amount, 167 times 6%. This amount, 167 times 6. Okay. So at the end of 26 year, you will get more money than you are offered with the option 1. Of course, because you have the highest interest. So you can do in another way to think. You are offered the option 1. And the cost of money, I mean the interest rate is 6%. If you discount the last year's payments you will receive, as the denominator is higher because you are dividing by 1 plus 0.06, as the interest rate increase, the present value of the last payments is decreasing as interest rate increase. So for example, with 3% interest rate, the 25th payment at present worth is 5 million euros. With 6% is just 2.46 million euros. So if you accumulate all the present worth, you will have today to invest 145 million euros to obtain that money. So you get more money with your annual installment you receive today, 167, than if you received a present worth of 149. So you have more money with 169. So I think the best for understanding this, Beatriz, I think is... Thank you, Alejandra. Leave, please. So the best thing I suggest you, Beatriz, is to try to reproduce with your Excel, try to reproduce this exercise and test yourself what are your expectations, what do you think your guess, and then try to confirm them. Okay, so sorry, excuse me, we were here. So as the final graph we have here, picture, with lower interest rates, as 167 million euros put in your bank at 2% is a low amount, you will prefer to receive the installment options. As you see here, the present value of the option 1, the installment option, with lower interest rate is preferred than the option 2. And inversely is the same, is inverse. In the case of a higher interest rate, you will prefer to have more money, today a lump sum, than the receiving installment, because you are discounting very, very much the future values, the future payments, you are discounted by 1 plus dividing by 1 plus 0.7, which is a high discount factor. You have here in this table the present worth of the annual installment. You see here with higher interest rate it decreases. So you will choose in any case the highest present value. In that case, the lump sum with the highest interest rate, the lump sum is the preferred option because the present value is higher. Okay, so if anyway we can see again next day, tomorrow no, on Thursday, and we can have a more a deeper view about that. So thank you very much for your attendance, and we will see next. No, I understand. I confused. Okay, present worth is present value. It's the same. Present value is for just a single payment, and present worth is for a series of cash flows. So it's the same word. Thank you very much. Bye bye.